This is the last video I have planned for the Boyle's Law Lab. This is the continuation of the analysis, and we're going to plot a few graphs. So I am on the last page, page 5, and I'm looking at question number 6. And it says, on your graph paper, I forgot to include graph paper with the lab. You can use graph paper that you have at home, or I included a link so that you can get some graph paper on GradeLink there on my teacher page. So on your graph paper, choose convenient scales and plot the average volume, which is column E in the above table, versus absolute pressure, P, which is column D. The pressure values should be on the x-axis and the volumes on the y-axis. The reason for that is because the x-axis is always our independent variable, which we changed the pressure, and the y-axis is our dependent variable, which because we changed the amount of pressure, it changed the volume. Be sure to label each axis appropriately. You may wish to review Lab 1B for graphing techniques. Connect the points with a smooth line that best fits them. What shape is the line? Well, before we can know what shape it is, we have to plot it. And so here's my graph paper. I gave it a title, Boyle's Law, Pressure versus Volume. And what I did was I looked at my data. And I know I did not finish in this table here, but I do have my data somewhere else because I did do this so that I could do a plot with you. And I looked at my pressure values, and my pressure values were all between 14 and about 22. I don't know, your pressure values will probably be about in the same place too. It depends upon the barometric pressure of the day that you did your experiment. But mine ended up being between 14 and 22. So I'm going to show you how to do a graph based on those numbers. You might have to adjust yours a little bit because yours might be a little different. I also looked at my volumes, and because we started at 45, all my volumes were between about 16 and 43. So I did go ahead and start with 0 on that. So I'm going to show you what I did. I'm going to just plot these few points that I have here because I want you to plot your points. I don't want you to copy my graph. So here is my graph, and I'm going to go down here, and it said that on my x-axis, I'm going to mark this as 0. On my x-axis, I need to put pressure. So I'm labeling that pressure. And my pressure is in pounds per square inch. So I have to have that label there so we know what unit we're using. Now, I also said that I didn't start till 14, and if I use this whole graph from 0 and go up to 22, it's going to be really narrow. So I'm going to put a break here. That's what this is. So go ahead and draw a squiggle, and I am going to start at 14 because my pressures actually start at 14.7. And I found that if I want to go up to 22, what worked really well was every 4. So this would be like 14.25, 14.5, 14.75, 15. And so I kept counting like that. So 25.5, 0.75, 16. 16.25, 16.5, 16.75, 17. So I get 1, 2, 3, 4 after 1, 2, 3, 4, 18. 1, 2, 3, 4, 19, 1, 2, 3, 4, 20, 1, 2, 3, 4, 21, 1, 2, 3, 4, 22, and it really does go up to 23. Okay, so that's a good scale. It will spread everything out. Now, on the side here, I want to go up to 45. And so I found that if I just counted by ones, that really spread it out. But I'm not going to write down every single one. I'm just going to write down every 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. So my numbers are very nicely spaced out on this graph. And oh, I better not forget to label my axes. Here, my y-axis, and this is volume in milliliters. So now I have that labeled. So the next thing I need to do is I need to plot my points. And for my points here, I have 14.7 and 43.5. So I find 14.7. Now, these go by 2.5. So 14.25, 14.5, 14.75. 0.7 is just a little bit before that. And I have to go up to 43.5. So I'm going to follow that line up and go up to, remember, these go by 1. So here's 40, 41, 42, 43.5. So I put a point there. Okay. My next one is 15.7 and 37.5. So again, I go down to here, 15.7, 15.25, 15.5, 15.75, so I'm just a little bit ahead of that. Go up that line to 37.5. So here I am at 35, 36, 37, 37.5. And I would continue plotting my points. Okay, so go ahead, pause the video, and continue plotting your points, and I will be back and show you what my full graph looks like, and we'll talk about question number 6. Okay, so you've had enough time to plot your graph, so my whole graph's not, well, it kind of fits on there. This is what my graph looks like, and when it's talking about the best fit line, it doesn't want you to connect the dots. It wants a nice smooth curve that follows the general pattern of the point. So my point here was a little high. I just kind of came down there, and I did not connect the dots. I made a nice smooth curve. And so question number 6 asks, what is the shape of the line? What is the shape of the line? It's not straight, is it? It's a curve. And what direction does it go? It goes down. So I said the graph is a curved line that slopes down. That's all you have to write. And, excuse me, your graph should look a lot like mine. If it doesn't, you did something wrong. You either have to go back and look at your calculations, or maybe you have to recollect your data. Question 7, what type of relation exists between pressure and volume is determined by your results, direct or inverse? This is an inverse relationship. As pressure increases, volume decreases. Okay, so that's definitely inverse that we talked about with Boyle's law. Now, they want you to plot another graph. They want you to plot 1 over V, which is column D in your data table, versus absolute pressure, which is column D in the analysis table. So 2 different tables. Be careful here. Okay, this is where I got caught up a little. I got a little mixed up in my numbers, and I started plotting them wrong and had to go back and erase a few points. Again, plot P on the x-axis and 1 over V on the y-axis. Choose convenient scales to spread out the data sufficiently. what is the shape of this plot? Is this what you expected? And you're like, I don't know. For the what is expected. But let's just plot the data table or the graph, and I'll show you what to do for that. Okay, I've lost my graph here. I had one all set up and ready to go. Okay, oh, here it is. I found it. Okay. So I gave it a title, Boyle's Law, P versus 1 over V. Okay, and again, the first thing we do is we put pressure down here. Now these values are exactly identical to your other graph, so just copy what you did for your other graph, okay? So I have 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23, yay. Now, the numbers along here are going to be different because this is going to be 1 over volume, and this will be milliliters to the -1 power because it would be 1 over milliliters, so that's why I write it this way. Now, my values for this are quite different. When I looked at my values for this, I go from about 0.02 to 0.06. And so yours will probably be pretty similar. So what I decided to do was I started with 0.02. Okay, 0.02. So actually I have a little break here. So, well, I could do with 0.01. Okay, so I went by twos, 2, 4, 6, 8, so I put 0.01. So this would actually be 0.01, or actually down here it would be 0.002, 0.004, 0.006, 0.008, 0.0010. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This will be 0.02. 1, 2, 3, 4, 5. 0.03. 1, 2, 3, 4, 5. 0.04. 1, 2, 3, 4, 5. 0.05. 1, 2, 3, 4, 5. 0.06. Okay, so that spreads it out pretty well on my graph because I have less than half left here, so I wouldn't have wanted to do any more than that. So I look at my values that I have. And on my graph, I have to be really careful. I'm using the pressure values from here and the 1 over volume values from here. So my pressure is 14.7 and my volume is 0.0230. So I go to my 14.7 here, which is just a little bit before 14.75, because remember this is 14.25. Yeah, 25.5.75, so a little bit before there. And I'm going up to 0.02, so that's here. Remember, this is 0.022, this is 0.024, so I'm halfway in between there for my point. With 15.7, I'm over here. This is 15.25, 15.5, 15.75, so just excuse me, 15.25, 15.5, 15.75, so just a little bit before that line. And my next value is 0.0267, which that's closer to 0.027. Okay, so I go up and I go, here is my 0.02, 0.024, 0.026, 0.028, so wait, 246, oh, up here actually. Be careful when you're doing that. So let me double check. 2, 4, 6, 8. So yep, right halfway in between there. So I want you to pause the video and get this down and plot your own data. Okay, so this is what my graph looked like, and it also said to do a best fit line, and this is pretty linear. I know my points here are a little high, my points here are a little low, so I drew a line kind of halfway in between there. That is my best fit line for this. So I'm going to answer my questions based on this. So the first question for 8, so I plotted my data, and I'm answering the question here. It says, what is the shape of this graph? Is this what you expected? So the shape of my graph is a straight line with a positive slope. And is this what you expected? And you're like, oh no. Well, this is what should be expected, and this is the reason why. Pause the video to copy this if you need to, and then listen to me. It is what is expected since pressure and volume are inversely related. Plotting one variable against the reciprocal of the other results in a linear plot. So if you were to take any data like this that had this inverse kind of relationship and do one of these plots of 1 over the number, you would find that you'll get a straight positive slope like this. So mathematically, yes, this is what is expected, even though maybe it's not what you expected because you haven't been introduced to this relationship too much. Question number 9 says, what pattern did you notice in the values for the product P times V in column F? Does this confirm Boyle's law allowing for experimental error? Explain. So that is looking at these values here, P times V. Now this value did not work out as nicely for me, I will admit, because what is expected is that P times V should be constant and should confirm Boyle's law, which states that P times V equals K, a constant, or P1V1 equals P2 times V2. Mine kind of, I put a note here, you don't have to copy this down, but maybe this is what happened to you too. Mine gradually decreased. And I'm thinking that that might have been due to some air loss, because especially once I put that plunger down, and when I took it off to put more water in, that plunger should have popped right back up to 45, but it really didn't. It kept going down. So I think I was having some air loss there, so I did not see that P times V stayed constant. Maybe you did better on this, so I'm interested to see what your data shows. But what should have been expected is that should have been relatively constant. And so then, what are some possible sources of error in this experiment? I want you to think about this for a few minutes. So pause your video and think about it, and then I will give you some sources of error that I thought about. So one source of error could be variability in the syringe volume readings due to friction of the plunger. We put oil on that plunger, but there still could be some friction there causing some issues. Another error is always errors in reading. Maybe you read the volume on the plunger wrong, or the volume on the water wrong, or you didn't fill the water just quite the same each time, because especially I used a measuring cup and there's quite a bit of variability there. So that could be a source of error, or just your readings were off. Maybe you spilled some water when you were adding it to the jug and you didn't feel like going back and starting over again. So that could introduce error. Temperature variations. Temperature is supposed to be constant, but maybe it wasn't. And then I finally also said air leaking from the syringe. I really think that this was an issue for mine. So that's it for the lab. Now what I want you to hand in with the lab, if you want to send it electronically, you can, but you can just send in these hard copies. And what I want stapled to the back of this, I want all the questions answered stapled to the back. I want your calculations that I asked for the data section and for the analysis section, and I want your 2 graphs. So you'll hand in the lab, the calculations, and your 2 graphs.